Okay, this is the second part of my video on quadratic inequalities, and this is a much more difficult example, but the principle's the same. So the question would be to solve minus x squared minus x plus 6 is greater or equal to 0. Okay, you can see that the function of x is more complex now. Now the problem with that now is we've got a minus x squared, and I don't like minuses, especially with the x squared, because the graph will be the other way around. So what I choose to do is to times everything by minus 1. This is one way of doing it. Obviously when you times by minus 1, then this symbol will have to swap around. So obviously that becomes x squared plus x minus 6 is less than or equal to 0. And now I'm in from there. Okay? If you didn't like that option, the other way around that is to go back to the original question here, x squared plus x greater or equal to 0, and rearrange it by adding x squared, adding x, minus 6, doing the inverse of those, and doing the same to that side, which gives you that. That now becomes 0 on the left-hand side. That is greater or equal, because that doesn't turn round, because we're not times or dividing by a negative number. And you get x squared plus x minus 6 as before. Now I work left to right, so I need to put that to the front, which is x squared plus x minus 6. And because you've got to be very careful, because it's not symmetrical, it's less than or equal to that, so you need to make sure that is pointing with the expression there. And I've got what I've got at the top of the board there. Okay. Now if I just rub that out, because that was just my other way of doing it, we can proceed with the question from here. So we've got x squared plus x minus 6 is less than or equal to 0. That is your function of x. You need to get it set to 0. So this is all this is y, because it's graphing it, and you are now, that is the key to it. You want to find where y is less than or equal to 0 on that graph. Okay? So you're going to graph y equals x squared plus x minus 6. I'll set my axes up here again, like all the other questions. There's x, there's y, there is the origin. Okay? Now if I just put on my here, as before, along the x-axis y is equal to 0. Above the x-axis, y is positive, so it's greater than 0, and below the x-axis, y is less than 0. That's my marker to be able to find that particular region for those values of x, because it's asking to solve for those values of x. Okay, going back to this graph here, we want two bits. We want the y-intercept as before. Now the y-intercept, as I said before, is down the y-axis here. Now down that y-axis, you've got many values of y, positive, negative, so x is 0. So you basically stick x equals 0 into here, and you get y equals 0 squared, replacing x by 0, minus 6. That leaves you with minus 6, which happens to be the end number, but that's not always the case for some functions later on in the course, and that means it goes through 0, minus 6. So I can put that on there as 0, minus 6. So as minus 6 on the y axis. Okay, so we've got that bit sorted there. If I just rub that out on here, rub it all up there. Okay, we've got y equals x squared plus x plus minus 6. Now the key bit now is to find the x-intercepts, which I call the roots or critical values, and they occur along the x-axis. So you go along here, along the x-axis there, you can see along there y is 0. So we set y equal to 0 in that, so you get x squared plus x minus 6 equals 0. And obviously now it's much more complex. The previous questions were simple ones. They're all difference of two squares when you were factorising. So you have to find two numbers which multiply to give you minus 6 and add to give you 1 in the middle there. So I'll just put the 1 in red there, because I usually do that. There's the 1. Okay. Now you're finding two numbers which multiply to give you minus 6, which is opposite, and a difference of 1 in the middle. I'll put diff of 1 there. So factors of 1 in front of the coefficient of x squared is 1, so 1 and 1. Factors of 6 are 1 and 6, or you could go 1 and 1 with the coefficients of 1 there, with 6, 2 and 3. We're looking for a difference of 1, so it's going to be the bottom one, 1 times 3, 1 times 2. Okay, so that now gives me two brackets. Again, you've got to be razor sharp on your factorising here. There's your 1 and your 1, which is your 1x and your 1x. That 1x has got to times with the 3, and that other 1x has got to times with the 2. 1 times 2. We want it more positive in the middle. So we've on the bigger expression, which is 3x compared to 2x, we put the positive on that to get the negative away, and you set that equal to 0. For the product of two things to be equal to 0, either of those could be 0, so x minus 2 could be equal to 0. If you add 2 to both sides there, add 2, you get x equals 2. If you do the other one, x plus 3 equals 0, take 3 off both sides, you get x to be minus 3. So the coordinates is when x is 2, y is 0, and when x is minus 3, y is 0. And they're called the x-intercepts, which are going to feature in the answer. So I'll plot them on there. There's the 2, there's the 2, 0, 2 x-intercept, on the x-axis, and there's minus 3. Now, like previous questions on the part 1 tutorial did, you can see that it's more, the y-intercept is bigger that side, so the graph is going to be more towards that side. In other words, the bottom part of the graph, the vertex, is going to be more that side. So the symmetry line, for the graph is not going to be along the y-axis. Okay. So if I go back now, okay, I'll just remove all this here because my key now is that in the box which I did earlier. We've got to find all the values of x where y is less than or equal to 0 by using that graph which I'm about to sketch. One other thing from that graph which I did there, just go back to it, when I changed it, I add y equals x squared plus x minus 6, yeah? Okay, on there. So, looking at that bit there, when I got a quadratic, ax squared plus bx plus c, because the number in front of the x squared is 1, a is 1, called the coefficient x squared, the graph goes that way around, and I made sure it was doing that. Just double checking I've got the right thing there from before. So, when I sketch the graph, it's going to be that sort of U shape, but you can see it's going to be the bottom part of the graph here is going to be more this side of the y-axis. So I just do a rough sketch, it goes down here, comes a bit further down, there's the vertex, which I'm not bothered about, comes back up here, and goes back through that point. It's not the best sketch in the world there, but the sketch of the sketch is just enough for me to solve this problem. Now, obviously, with my red pen here, I'll try and make this stand out a bit clearer. We want to search on that graph where y is less than or equal to 0. Now, if you go along here, y is greater than 0, so that's not going to feature, so I don't put a red line here. When I get here down to this point here, y is 0, which I want that it equals 0, so I put a shaded circle there. And obviously anywhere down this curve here, I'll try and put this in, make this a bit more clear in red here. Anywhere along here, all the graph there is y is less than 0, so I want that in this, in my solution there. Obviously when I get back here, y is equal to 0, well I want the equals 0, and anything above the x-axis there, y is bigger than 0, which I don't want. So I want this bit in the region there. If I bring the x-axis across here, I'll draw it underneath here, draw my x-axis again here, there's 0, there's the first critical value, y-intercepted 2, there's the other one, minus 3. Now obviously you want y to be less than or equal to 0, which is the red part of the graph, so obviously you're going to move all values of x from here to there, because if you move along there, you're reading off values which are less than 0 or equal to 0 on there. So it's all on there, so actually you're going to include the minus 3, and you're going to move this side, so all your values of x are going to go that way, and obviously less than or equal to 2. And there is what we've got, what I call a sandwich inequality, and the solution comes from that. X is between those two values, including the two numbers. X is greater or equal to minus 3, that way, but it's got to be less than or equal to 2. And that is the answer to the problem after going through all that. That's a high grade there, grade 8, grade 9 I would say definitely this is. Okay? And just to finish off from that, there's an exercise in the book. It's section, what you need to follow on from is from the original section on the easy stuff. It's section 13.2, so you can work from home on this. It's actually exercise, let me just get my exercise. It's again exercise 1, okay, on section 13.2. And I'd like you to look at questions 6, 7 and 8. There's loads of questions there. Some have got minus x squared. You can pick them off, differentiate what you want, but the more you do, the better it is. And that concludes all the work you've missed on quadratic inequalities. Hopefully that will be all right. If you can use this video, but you can also use the sites I've given you, Corbett Maths site and the Maths Genius site. I've got videos on there to back this up. I'll send this through as I show my own work to the work that needs to be caught up over the holiday. Thank you very much.